Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
These regulatory changes really do inspire new waves of capital to flow into the industry and new things to happen, which have the potential of making things better, making things safer, bringing new capabilities to market. And that's the opportunity that I see with MOSAIC today, is that MOSAIC, in my view, is actually bigger than either Part 23 Amendment 64 or the original LSA rule, Sport Pilot Led Sport Aircraft rule. In my view, this is the biggest regulatory change of this century in the aviation industry. It represents a transformational opportunity on the safety front, on the novelty of the products that can be practically brought to market. It's incredibly exciting.
Hey everyone, welcome back to The Vertical Space and our conversation with Carl Dietrich, founder, CEO, and CTO of Jump Aero. We start with Carl's professional arc through aviation from the Terrafugia days to Jump Aero, including involvement with the Part 123 rewrite and ASTM standards. We discuss the history of light sport aircraft, when and why it was introduced, and the significance to the GA market. The heart of the discussion is Carl's context to what led up to the proposed modernization of Special Airworthiness Certification Rule known as MOSAIC. We discuss when MOSAIC was first proposed and why, how it changes the LSA definition, and very cool, how significant this change could be to the growth of the GA market. We discuss how MOSAIC potentially creates a faster path to market for certain types of aircraft. Carl walks through using the Jump Aero aircraft, what it would be like bringing the aircraft to market using MOSAIC versus the standards that exist today. Then Carl addresses Luka's question of what advanced air mobility vehicles today can be brought to market using the proposed new MOSAIC rules. We then discuss the light sport aircraft standards in Europe versus the United States and the potential for LSA harmonization. Carl is the founder, CEO, CTO of Jump Aero, where he and his team are developing a high-speed, all-electric vertical takeoff and landing aircraft system to help first responders save lives. At an industry level, he serves as the chairman of GAMA's Committee on Simplified Vehicle Operations. He's the author or co-author on 3 issued patents and multiple pending patents. Carl earned his BS, MS, and PhD from MIT's Department of Aeronautics and Astronautics. Prior to Jump Aero, Carl founded and led Terrafugia as CEO, CTO from the inception in 2006 through its acquisition in 2017. Carl spearheaded the development of the first integrated rotable aircraft capable of converting between flying and driving in less than 30 seconds. He developed and ran a world-class R&D center for Terrafugia focused on the development of novel eVTOL configurations and business plans for the emerging urban air mobility market. In addition to his work at Terrafugia, Carl helped develop the standards for light sport aircraft on ASTM Committee F-37. During his 11 years at MIT, Carl founded the MIT Rocket Team, won 4 out of 5 design competitions, and won the $30,000 Lemelson MIT Student Prize for Invention. In 2000, he was recognized by the MIT Aero Astro Department as one of 16 young alumni who have shown extraordinary accomplishment and subsequently received 40 under 40 awards from the Boston Business Journal and Aviation Week and Space Technology magazine. Our many thanks to Carl for being willing to answer all of our questions. And to our listeners, we hope you enjoy our conversation with Carl Dietrich as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by Avionics. Avionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let Avionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. Avionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. Carl, welcome to the Vertical Space. It's a real pleasure to have you on the show.
Thank you. No, it's great to be here.
Is there anything that very few in the industry agree with you on?
Yeah, I think it's a great question. So as you know, my current venture, Jump Aero, is very focused on what I would call more humanitarian use cases for eVTOL technology. In particular, we're looking to use eVTOLs to help first responders get to the scene of rural emergencies as quickly as possible. And in my view, I'm not just doing this because I think it's a great humanitarian exercise or it's some charitable sort of thing. I'm actually doing it because I think this is the highest rate of return on investment opportunity for eVTOL technology. And that is obviously not a commonly held view. Most people are focused on it either for personal use or for air taxi use. And when you look at the technology itself, you can see that electric propulsion, distributed electric propulsion, enables a lot of new things. It enables more robust propulsion systems in their distributed nature. Single failure may not take out the aircraft. Compare that to a helicopter, that sort of thing. It enables potentially lower cost operations. It enables potential green operations. The thing that we recognized at Jump Aero is that using an all-electric aircraft enables faster response operations. And that's something that I think we were a bit different, and that hasn't been widely recognized as a significant advantage and a real use case, broadly speaking. But in my opinion, this is actually the best go-to-market use case for a whole variety of reasons that I can get into, and it depends on how long you want me to talk about it. But the summary is that as time goes on, more and more people are going to want this more and more as they learn about the possibilities. Some of the other use cases, as they learn about some of the realities of the other use cases, it's going to throw a little bit more of a, well, okay, it's not going to be accelerating the rate of adoption. Whereas this use case, as people learn more about it, it should help accelerate the rate of adoption. And that's one of the reasons that I'm really excited about it.
What unique insight gives you clarity into this use case as opposed to most others in the AAM industry?
I spent a number of years at Terrafugia looking at both personal use, eVTOL through our TFX explorations in the early years between 2011, 2012, and 2015, and also the air taxi business models for the TF2 between, say, 2015 timeframe and 2019. And so we really dug in, both on the technology side and the business model side. And look, there are opportunities, but there are also significant challenges. On the personal aircraft side, to bring a personal aircraft within use of a real mass market potential, to you really have to drive down your costs. This was one of the things that killed our transition program at Terrafugia. The costs got too high, basically, and it killed the market. The GA market is very price sensitive. There are lots of used aircraft out there. Unless you're bringing something totally revolutionary to market from both a capability and price point, you're not going to win in the space, right? So a lot of eVTOL companies are coming out with low cost, entry level personal transporter things that look really cool. And I really am a fan of that. And I hope that they work. The problem is when you do that, you're driven to small batteries. And when you have small batteries on board an all electric aircraft, not only do you have reserve challenges, but you've got battery cycle life challenges, and you're going to wind up replacing the batteries very frequently. And that's something that, when you sell initially to a customer that's, enthralled with the vision of what you've created, they may not be thinking about that. But a few months in, if you're replacing your battery pack already, that's going to become a real challenge. And it's not going to be a business that's going to be well set up for the long run. And that's one of my concerns about the personal market for these aircraft, is that because you're driven to drive down the price point, you're driven to make it small, and you're driven to basically have a battery that you're going to have to replace very frequently. On the air taxi side of things, it's more the politics. It's the airline business model, right? You've got to keep your seats occupied. You've got to keep your assets in the air as much time as possible. It's pretty straightforward what the economic drivers are. But in the markets where you potentially have enough demand to keep all the seats occupied all the time, you've also got a lot of local politics to deal with. And that can become an issue. And I don't think it's just noise that is the problem. It is some people just don't want things flying over their heads. And the local politics will wind up being the throttling function on both the rate of adoption of air taxis and how big the market gets in the long run. I wound up becoming a little bit more pessimistic about after we really dug into the specifics of where the demand was high. We spent a lot of time looking at the markets in New York and a couple of other locations, and it really comes down to, the local port authority can throttle your cost basis, and you got to live with that. That's a challenging business. It's one that is really hard to predict where it's going to go. Hopefully it goes well. There's definitely potential for reduced cost compared to helicopters. There's definitely potential for reduced noise compared to helicopters. I definitely think it's going to be bigger in the long run than the helicopter air taxi market. How much bigger? That's the thing that I think is hard to put a pin on right now. This use case, the one that we're pursuing, is one that, we've yet to find somebody that says, oh yeah, that's going to be a huge problem to you're going to find all this political resistance. No, there's no political resistance. It's just this is a true greenfield market. It's not like people are doing this right now. And that's our challenge, actually, is that because nobody's doing it right now, I can't point to Blade and say, oh, Blade's already operating this air taxi business. Nobody's operating a first response aircraft business. There are helicopter air ambulance businesses, but they are not used as first response. They are never first boots on the ground, except in a search and rescue capacity, which is a completely different mission.
I'm sure we're going to peel this back later, Carl, but given that you said that it's the one area that most people won't agree with you on, what's the economic justification for the product? What's the return they get from an emergency response vehicle? And how do they justify it if you're saying the ROI for this is greater than anything else in the eVTOL market? We can go into more detail later, but that's quite a claim. And I'm a little perplexed.
I'm not saying the ROI. I'm not saying absolute ROI. I'm saying rate of return. If you're looking at aircraft development programs, now there are lots of other businesses in advanced air mobility that are not aircraft development programs. But from an aircraft development program perspective, I believe it's the highest rate of return.
What's the economic justification for the customer for the vehicle?
Yeah, that's a great question. So the way that the economics of a first response business works is it really depends on how many people can you provide life-saving service to. If you go on contract with a county medical director to provide an ambulance service, let's say in some particular county, typically the way those contracts are structured, you have to respond to a certain percentage of your calls, typically like 80% of your calls, within 8 minutes. And the reason that 8-minute window is so important comes down to basically medical reasons, physiology. And it's like, if you have a time critical emergency, like cardiac arrest, a stroke, any sort of scenario like a severe trauma where you're bleeding, any sort of scenario where you are likely to lose a significant fraction of the flow of oxygen to your brain, you are really on the clock at that point. And if you can get oxygen restored to your brain within 5 to 10 minutes, you've got a shot. Between 10 and 15 minutes, you got severe brain damage, coma, and by the time you're out at 15 minutes without oxygen to your brain, you're dead. So the average first response time today in rural America for 1 in 5 Americans is 14 and a half minutes. So on average, if you have one of these severe life-threatening conditions, cardiac arrest, stroke, et cetera, severe injury, even choking or allergic reactions that can cut off the flow of oxygen to your brain. Like these things can become life-threatening very quickly. And those are the opportunities. So there are 3.4 million time-critical emergencies every year in the United States. About 1 in 5 of them happen in rural areas, right? It's about approximately the rural population of the United States, right? And you've got about, I said the average response time is 14 and a half minutes, right? In urban areas and suburban areas, the average response time is 7.5 to 8 minutes. So that's what we enjoy in cities and relatively densely populated suburban areas where it makes financial sense to have a high enough frequency of fire stations to provide very timely first response. In rural areas, the economics are not there to justify that today with an ambulance because you've got a low population density. And so what often happens today is you've got a volunteer fire department. You don't have a team of professional first responders standing by all the time ready to go. you've got people who have other jobs, and a 911 call happens in a rural area, and it might take half an hour to get somebody to you. In fact, there are 4.5 million Americans that live in what they call ambulance deserts. These are areas where it takes more than 25 minutes to get help if you call 911.
Let's put a pin on this and pivot to the main topic of today's conversation, which is MOSAIC, or the Modernization of Special Airworthiness Certification, the proposed MOSAIC rules. And to have a more meaningful and a better conversation about the proposed rule itself, but also its impact on general aviation, as well as implications on advanced air mobility. Let's take the next 5 to 10 minutes framing the conversation through your own professional career, your own arc throughout aviation, from your time at Terrafugia through Jump Aero, your involvement with the Part 23 rewrite, with the various ASTM standards developments, and then obviously interacting with the FAA at each step along that way. So give us a comprehensive context to the discussion about MOSAIC.
Back in the early 2000s, the FAA recognized that most of the innovation was happening in the kit market. And I mean, and this actually extends back even before the early 2000s. As you guys know, the history of the general aviation industry, in the 70s, the industry was producing 15,000 units a year. And then in the early 80s, the industry was crushed, and it was crushed by products liability. And, Cessna stopped selling 172s. The industry as a whole almost went entirely out of business in the 80s. Come the early 90s, Congress passed the General Aviation Revitalization Act, and that limited manufacturers' liability for their products that are in the field to 18 years after the date of manufacture. The problem was that you had these old Cessnas that had been in the field for 30 years or more at that point that would crash. And then, of course, the estate sues the manufacturer, sues any deep pockets that are all associated with it. And the manufacturers were paying out a fortune, and they decided, look, this is just not a good business to be in at all, despite their extreme competence at making aircraft. When GARA was passed in 94, it made it financially viable to sell a general aviation product, frankly, because for a while they were right to be getting out of the business. It just wasn't financially viable. You had no limit, you had no way of quantifying how much liability you would encounter from shipping a product.
So GARA put a ceiling on that liability?
GARA put a ceiling of 18 years. Now you can limit it. Now you can budget for it. Now you can factor it into your cost of the aircraft, right? That was great, but also when you do that, the aircraft that were being sold at $400,000 to $800,000, and so the bulk of the GA market was buying kits or buying used airplanes. So it was helping with the used market significantly. The new market, though, is still significantly suppressed. And there had been a lot of technology advances that the FAA recognized actually had the potential to improve safety, but manufacturers didn't invest in them because it didn't make financial sense. The return on investment wasn't that great. So, you basically had all the interesting stuff happening in the kit market. So but the kit market is completely unregulated. There's no quality control. There's no uniformity, and the accident rate is still very high. So in the early 2000s, the FAA decided, hey, wouldn't it be great if we could actually make it, and they didn't use this language, but how could we potentially enable some of these new technologies, glass cockpit, avionics, and angle of attack indicators, and things like that have the potential to enhance safety? How could we get them out on new products? Because you had a fleet of aircraft that, frankly, all those aircraft were built in the 50s, 60s, 70s that were, frankly, getting towards the end of their fatigue lives. And at some point, you're going to start getting accidents just due to these airframes are incredibly old. And they've been in the field for a really, really, really long time. And airframes can wear out. So the FAA, I think, very wisely recognized that, hey, this is coming. this wave. We need to get some new stuff out there that people will want to buy, that companies will want to make and people will want to buy, and because it's the only way of potentially enhancing safety, right? People are not going to want to just voluntarily give up their old airframe and write it off. That's not going to happen. So how can we get them out of the old stuff and into something that is more modern and safer? And they came to the conclusion, and again, nobody officially says this, but I think that this is a lot of the reasoning that goes into it. They came to the conclusion that certification is a significant barrier, and in the early 2000s, they recognized that there may be an opportunity to achieve a lot of the realistic safety of certified aircraft without formal certification through the adoption of industry consensus standards and declared compliance to consensus standards. So the FAA performed an experiment effectively with the creation of the Sport Pilot Light Sport Aircraft rule in 2004. And when they did that, they limited it very significantly, right? They limited it to 2-seat aircraft, maximum gross takeoff weight of 1,320 pounds or 1,430 pounds if you're amphibian, VSO of 45 knots, top speed of 120 knots. Very limited in terms of what the aircraft can do, but it's a real aircraft. It could be used for trainers. That was great because you had a lot of really old 150s, Cessna 150s and 152s that have been getting beat up for a long time in the training field. And at some point, fatigue sets in, right? So if you could get a new fleet of trainers out there, that would potentially enhance the safety of the overall GA fleet. So they created the Sport Pilot Light Sport Aircraft rule. And for the past now almost 20 years, we've been collecting data, right? The industry and the FAA has been collecting data on what is the actual fielded safety, the realized safety of these aircraft that were brought to market, not FAA certified, but through the consensus standard process. And it turns out they are significantly safer, statistically speaking, than experimental aircraft or kit-build aircraft, which makes sense because they're made at a manufacturing facility. The manufacturers have to worry about their own liability. They have all of the same sort of financial incentives that the big certified manufacturers do to not sell dangerous products that people kill themselves in, right? So the reality has shown that these aircraft are significantly safer than kit aircraft, not quite as safe as certified aircraft, but they fell where the FAA was expecting them to fall on the safety spectrum. And that concept of the safety spectrum is one that's not widely talked about, but it is well established in the industry.
Carl, let me just react real quick. When I looked at some safety statistics numbers recently, LSA aircraft, light sport aircraft, are about 5 times less safe, or I guess the accident rate per 100,000 hours is still about 5 times greater than the certified aircraft. And what I'm not really certain of is whether this is due to certain design qualities of the aircraft, light control forces or much lighter wing loading of these aircraft that make it really difficult to maneuver and control given high winds or gusts. And most of these accidents do occur at landing and takeoff. Or is it because at the same time, the FAA reduced the requirements for pilot certification for sport pilots? I certainly want to get back to the track that you're describing, the story, but how does the FAA then view the trade-off between lowering the thresholds for pilot certification as well?
So the idea and I think it's great that you bring that up because they did create the new sport pilot license at the same time as they created this new category of light sport aircraft. And that sport pilot license has a 20-hour minimum instead of a 40-hour minimum. Now, you still have to pass the tests and that sort of thing. So like in practice, it wound up being 35 to 40 hours instead of 60 to 70 hours, something like that, compared to a traditional private pilot license. And there are some differences, right? They get rid of the requirement for night flight training. They get rid of hood time. There are a number of things that they take out to allow that type of sport pilot flying. But in your underlying question of like, I'm not sure we're able to extract what is a result of less of the 20-hour minimum versus the 40-hour minimum versus, I think I think anecdotally that there is concern that there's more concern around light wing loading and handling in gusty conditions and, being a little bit more squirrely and realizing that, hey, maybe that 1,320 pound limit wasn't actually as much of let's say there wasn't as strong a safety basis for why that limit was put in place. And I think that we're sort of seeing some of the recognition of that with the new MOSAIC NPRM. But I don't know if you can actually extract the question of training versus the light wing loading and the fundamental characteristics of the aircraft.
Fair enough. All right. Apologies. Go back to your story.
No. It's a good question. Like I don't know the answer, and I mean, I'm sure there are people that are more expert on that particular topic.
I mean, part of the reason I ask is because we'll get to this, but the impact and the implication of simplified vehicle operations in the context of plugging some of the holes here in the actual pilot qualifications might actually play a really, really interesting role in MOSAIC, but I'm sure we'll get to it.
Yeah, absolutely. I think that it's a tremendous opportunity that's created by the simplified flight controls construct that they've added to the MOSAIC rulemaking. I think that's absolutely huge. So coming back a little bit, so 2004, the FAA creates sport pilot light sport aircraft, creates this new category of aircraft that are not FAA certified, where the industry just declares compliance to consensus standards, ASTM standards, and a fleet is deployed. Something like 5,000 LSAs out in the field today. So big enough fleet to get some reasonable statistics and out there for a long enough time. And so at this point, there are always desires to improve safety. And with the recent NPRM, I think there is a little bit of an acknowledgement along the lines of what you're saying that, hey, maybe that weight limit that we put in place and the 45 knot stall speed combined with the weight limit, you're a pretty light wing loading aircraft, and the structure may not be quite as robust as maybe would be desirable to have in a new Cessna 150 trainer or some sort of replacement type trainer aircraft. And I think that sort of bears out if you look at the history of the 162 Skycatcher that Cessna put out that they then canceled, right? It was not quite beefy enough to be a good replacement trainer for the 150 and the 152. Anyway, the bottom line though is the numbers, the accident data are approximately where the FAA was hoping that they would be. They would be better than the kit market, right? Better than the kit, not quite as good as FAA certified aircraft, but where they would expect them to fall on the safety spectrum. As a result of that, they say, okay, well, there's reason to be optimistic that maybe if we continue down this path and open up the use of consensus standards, maybe it will increase investment in the space, increase the novel technologies coming out that have potentially safety enhancing characteristics. So you had the Part 23 Amendment 64 come out, and there was a whole aviation rulemaking committee that basically looked at what happened in light sport. And this was, I believe, 2012, 2013, 2014, where the Aviation Rulemaking Committee looked at the relative success of what happened in LSA and basically changed Part 23 and took out a lot of the prescriptive language in favor of what they call performance-based rules, and then took the prescriptive language that had been in the previous Amendment 62, Amendment 63, and put them in the consensus standards. So there was a huge effort that went on to move a lot of the prescriptive language from the regulation itself, which is very difficult to change, take it out and put them in industry standards, which are easier to change, but have to be done through a very formal consensus process. So that then we wound up with Part 23 Amendment 64, which was a major step forward in terms of this new way of structuring aviation regulations themselves.
Carl, what were some of the notable projects that took advantage of the rewrite of the Part 23?
Actually, a lot of them are still in the works right now. In fact, the original certification bases for almost every one of the major eVTOL companies out there were based on Amendment 64 of Part 23. Like it really did open up the possibility of a little bit more flexibility on how you show compliance Including, we drafted a cert basis for our product that was based on Part 23 Amendment 64. And then when the FAA pivoted to adopting more the powered lift take and the 2117B process, we still took all that language from Part 23 Amendment 64, that all of that same language still applied. I would say that language propagated into the cert basis of basically every new project that's out there today is looking at the language that was written of Amendment 64. And even if they're going through a 2117B special process, they're referencing in their cert basis, in their G1, they're referencing the Amendment 64 language.
What were some of the most notable changes moving from a prescriptive to a performance-based aspect of means of compliance?
The regulation itself became less prescriptive and became more performance-based. But all of that prescriptive language was moved from the regulations into ASTM standards. So it still exists. It can still be used as means of compliance, but it is not the only means of compliance. Whereas when it was in the regulation, you had to abide by the regulation, or else you have to get a special condition or something like that. You needed a special workaround to say, oh, that doesn't apply to my project. So the idea of Amendment 64 was that by focusing on performance-based rules and then putting means of compliance with all the specific prescriptive ways of complying with that performance-based rule in an industry standard, more industry standards can be written and the FAA can choose whether to accept them or not on a case-by-case basis and choose the applicability. And that's why now we have, you've got the G1 that is your cert basis, and then your G2, which is your means of compliance to the performance-based rule language of your cert basis. So Amendment 64 comes out. It inspires, frankly, with each one of these rule changes, you do see a significant amount of new investment in the general aviation space. So, for example, when the Sport Pilot Light Sport Aircraft rule came out, a whole lot of new companies came into the market, including my first company, Terrafugia. We were founded in large part because of the creation of the Sport Pilot Light Sport Aircraft rule, because now we had an avenue where we didn't have prescriptive language in Part 23 that we had to comply with, and it opened up the possibility of doing something new and different in the general aviation market. In our case, a roadable aircraft that would actually be capable of meeting federal motor vehicle safety standards and the ASTM standards that complied with that we needed to declare compliance with for a light sport aircraft. So when those regulatory changes happen, because aviation is such a highly regulated industry, it does open up new opportunities. It does catalyze new investment in the space. We've seen this happen now a number of times. So back in 2004 with the Sport Pilot Light Sport Aircraft rule, and then with Part 23 Amendment 64 and the subsequent wave of new technology companies that came to market and are on various different paths to market, whether eVTOL air taxis or autonomous aircraft or what have you. So these regulatory changes really do inspire new waves of capital to flow into the industry and new things to happen, which have the potential of making things better, making things safer, bringing new capabilities to market, et cetera. And that's the opportunity that I see with MOSAIC today, is that MOSAIC, in my view, is actually bigger than either Part 23 Amendment 64 or the original LSA rule, Sport Pilot Light Sport Aircraft rule. In my view, this is the biggest regulatory change of this century in the aviation industry. It represents a transformational opportunity on the safety front, on the novelty of the products that can be practically brought to market. It's incredibly exciting.
Okay, Carl. So unpack that for us a little bit more. And in particular, the aviation press covered the MOSAIC rule at a high level when it was released in July, but open it up more for us, in particular from the perspective of the AAM community and the type of technology that they're aiming to bring to market and how MOSAIC is going to accommodate that.
We've got a few big technological thrusts that are impacting aviation today. We've got electric propulsion, distributed electric propulsion concepts. We've got autonomy. These are sort of the two big areas that are attracting a lot of new investment and have a lot of potential to affect the industry in the long run. And so what MOSAIC does is it gets rid of the old definition of a light sport aircraft. And the old definition, as I said, was limited in weight, limited in stall speed. It was limited to a reciprocating engine. So you actually couldn't bring an electric to market as a light sport aircraft. With the MOSAIC NPRM, now you can. Not only can you bring an electric, you can bring a powered lift aircraft to market. You can bring a helicopter to market. You can bring an aircraft with a fly-by-wire simplified flight control system to market. So these are huge opportunities for industry right now. It gets rid of the specific prescriptive weight limitation entirely. It instead focuses more on performance. The performance is limited, but now it's limited to 250 knots of speed, which is tremendous. That's fantastic for general aviation products. The stall speed for fixed wing typical airplane is still limited to 54 knots now, as opposed to 45 knots. Passenger carrying capability is still limited if you're a fixed wing airplane to 4 seats. If you are any other type of light sport aircraft, of which now there can be basically any type of aircraft you can imagine, could be a light sport aircraft, you're limited to 2 people on board the aircraft. So, but that opens up a tremendous range of new products, avenues to bring simplified flight controls to market. As you guys know, I chair the General Aviation Manufacturers Association's Committee on Simplified Vehicle Operations. It's been very clear for some time that the rate of loss of control in flight, it's not getting a whole lot better very quickly through just trying to improve training. We're sort of statistically up against a limit of, people just forget their training or don't fly as often as they might in a Part 121 operation or a Part 135 operation when you're operating under Part 91 for personal flight. And, we're sort of at that limit of, you got one loss of control incident happening every 100,000 hours or so, right? And it is the single leading cause of fatal accidents in general aviation today and has been for a long time. And through training, we're really not able to move the needle significantly. And there have been lots of efforts. I'm not saying it's not worthwhile to continue to try, but in order to have the potential to significantly move the needle on loss of control in flight, we need to bring some real full envelope protection systems to market. And the only way to truly implement a full envelope protection system is with a fly-by-wire system. And that when you do that, it's a complicated system. It's a highly engineered system. And one of the challenges is going to be, do the entrepreneurs out there, do the investors out there see the potential return on investment, right? The FAA is opening the window of opportunity with the MOSAIC NPRM, assuming the NPRM becomes the rule. They're opening the window of opportunity for simplified flight controls, which have implicitly this full envelope protection and could enable fundamental improvements in the safety, in the mitigating that loss of control in flight. And also open up the market significantly, right? If we can make it easier to learn how to fly an aircraft, by eliminating the need for upset recovery, incipient stall training, any sort of spin training has been off for a while, but there's the possibility of making it just much easier to fly safely. And that's the opportunity that I think the FAA has recognized here by including simplified flight controls in the MOSAIC NPRM.
Okay, so lay out the comparison of the process that a startup would go through bringing an aircraft to market using what MOSAIC is going to define compared to a startup bringing a roughly comparable eVTOL to market under the powered lift certification process that we see the major eVTOL players in the United States all going through.
I want to be very careful not to imply that everything is known about that path today, because standards must be written still. For instance, for personal eVTOL, let's say, standards must be written for personal eVTOL that are comparable to F-2245, the design and performance standard for light sport aircraft that was the primary design standard for light sport aircraft up until today. So there is no primary design standard for an eVTOL aircraft at this point in an ASTM standard. So what is likely to happen is that the industry, those industry players that are motivated, potentially interested in bringing a product to market through this new opportunity of MOSAIC NPR rule, we need to write some standards. And we need to create those standards. And the best way to create those standards is by looking at the certification bases and the means of compliance, the public G1 and G2 papers that are out there for the big eVTOL manufacturers, seeing what they needed to do. And in some cases, for instance, in the most advanced projects that are out there right now, like the Joby project, they've got a cert plan that is fairly well laid out. There are still a few elements of their certification plan that they're still working out, particularly in terms of the flight testing, what the mission task elements are that they're going to need to demonstrate, the comprehensive list of everything. Once that is all established and out there in a matter of public record, the industry can look at all of that and say, let's fold that into an industry consensus standard, or fold in the parts that make sense for an LSA eVTOL. Once we create that consensus standard for design and performance of an eVTOL LSA, and the FAA accepts that standard, which is the second part of the process, the FAA actually has to be willing to accept it, then you could conceivably declare compliance, and you need to have a trained person on your staff that understands all the ramifications of declaring compliance to an industry standard. So that person has to go through a training course and that sort of thing and understand really what it means to declare compliance. But if you do design and test your aircraft to be in compliance with those standards, in the case of the previous generation of light sport aircraft, that was F-2245, and you do all the other necessary things, you have to have a pilot's operating handbook, you have to have continued airworthiness requirements, maintenance, et cetera, there are specific things that you must do in order to be able to declare compliance. And then the FAA will audit you, or there will be a third-party audit to make sure that you're not obviously lying. And at that point, assuming that everything looks okay, and of course, what happens is they find some issue and that they point something out, and you make corrections and go through that process. But the important thing about it is the FAA is not certifying the aircraft. So the FAA is not witnessing your tests. That's very important, right? And it's not because the manufacturers are trying to hide anything. It's because scheduling things with a giant government bureaucracy that has to treat everybody equally is hard. They have resource constraints. They're the only project that those FAA folks are working on. Whereas for your employees, this is their full-time job, right? If we need to come in on a Saturday to complete a test, that's what we're going to do, right? To meet a schedule, you're not going to get that out of the FAA. And there's nothing wrong with that. It's just, it's not going to happen. So, and in fact, if something happens where you can't perform a test on the day that you were scheduled to perform a test in an FAA cert project, you might have to get back in line, right? Because the FAA, those guys now have a bunch of other projects that they're responsible for, and they've got other things that are on their calendar, right? So this is one of the reasons that certification takes a long time. It's not the only reason, but it is certainly one of them. It's not that the FAA is out to get anybody or anything like that. It's simply that the reality is that they're a giant bureaucracy that has to treat everybody exactly the same.
And so MOSAIC creates a path that is potentially a faster path to market for certain aircraft, one that may provide more clarity at the outset for what that path is going to look like. But the particulars depend upon the existence of the relative standards respective to the configuration and the design aspects of that aircraft. And so why don't we use your aircraft that you're building for Jump Aero as an example and get a feel for what that process would look like for that aircraft. I mean, you're considering bringing that aircraft to market under this new rule. Why don't you describe for the audience briefly the configuration, the key aspects of it that are relative to this and what that process would look like given where the state of the standards today?
Yeah, absolutely. So Jump Aero is making a single person emergency response eVTOL that has 8 primary electric propulsors. It has 8 batteries that are cross-linkable and able to power, so we can tolerate any particular motor failure, any battery failure, any actuator failure, basically any single component failure we can tolerate and still perform vertical landings. The aircraft has very high lift to drag ratio, so we're able to, throttle back and extend our range if we need to. There are important safety aspects of the aircraft that come when you're developing an all-electric aircraft. Battery safety is a huge one of those aspects. High voltage safety is another. And these are things that they're new to the aviation industry in general, relatively new. Very high voltage propulsion batteries are relatively new, right? And the way that those batteries can fail and how do you treat those failures? So for instance, in our aircraft, our batteries are not just physically isolated from one another, but they're physically isolated from pilot and the passenger compartment. So they vent directly to the free stream in the event of a thermal runaway. It's part of the philosophy of how you design the aircraft. In our design, we assume that everything could fail at some point, right? Anything could fail at some point, and we don't want any of those failures to cause the aircraft to not be landable in a controlled way. And that philosophy of what we call fail functional is one that actually I'm a big fan of, and I think actually needs to be highlighted a little. I made a comment actually on the proposed MOSAIC. This is one of my comments are just very positive about MOSAIC in general, but one of the areas that I think should be emphasized a bit more for a simplified flight control aircraft, it's not just a standard fly-by-wire aircraft, because a standard fly-by-wire aircraft typically has a reversionary mode that is a direct law, meaning it can act like a traditional airplane where I have a direct linkage between my sticks and the flight control surfaces. In a simplified flight control aircraft, that's not how you fly the aircraft. In fact, it's defined very clearly in the new proposed 22-180 that you're controlling the flight path of the aircraft. You are not directly manipulating flight control surfaces in any way. That's an important distinction. And it's very important that even in the event of likely failures, and the word likely is very important in the context of AC 23-1309, which is a advisory circular pertaining to reliability of systems. And basically, in the event of likely failures, we still need the aircraft to behave in the same way and not revert to some direct law mode or something like that. And so that is a requirement of a simplified flight control aircraft that is fundamentally different than traditional fly-by-wire aircraft. And it's important to call that out because a lot of the time you'll look to traditional fly-by-wire systems for best practices. And this is an area where we're saying that's not the best practice. And it's an area that I think needs to be made a bit more explicit in the new, whether it's in the new regulatory language or in a standard is still TBD. We can make it clear in the standard if the FAA doesn't choose to make it clear in the regulatory language itself. But in any case, it's important from a safety perspective that the way that the pilot interacts with the aircraft does not change in the event of any single component failure that's likely to occur on the aircraft.
What limits does MOSAIC place on the ability to commercialize LSA aircraft? How much of the use cases in AAM today could be brought to market via MOSAIC?
The personal use could be brought to market via MOSAIC. Our use case could be brought to market via MOSAIC. It's possible that perhaps some like firefighting or observational, other use cases like that could be brought to market via MOSAIC. The air taxi model that's a 135 operation, so that is something that you need a certified aircraft to perform. So it should not impact the the Jobies and the Archers of the world, but for the personal use vehicles, the openers of the world, and that sort of thing, it could make a big difference.
Isn't there also a limited set of commercial operations that you can do? And I think off the top of my head, it's flight photography. So perhaps you could do inspection missions with it, agriculture. What other sets of missions can you do? And how do you see these kinds of vehicles perhaps even taking share from larger UAS systems that are brought to market for these same use cases?
That's a tough one, because of course you are required to have a pilot on board these aircraft. So, for any sort of commercial use case, you need to be able to support, the business model that has a person on board. There are, and I think you mentioned a good number of the potential business use cases for light sport aircraft under the MOSAIC rule, it's very exciting. Obviously, flight training was always meant to be part of but opening it up beyond to other business use cases outside of just the straightforward training market is really, really impactful potentially on the entire industry. Certainly on our use case of first response, that makes a big difference. The drone side is tough. You have to look at the economics of it. I don't know offhand, for instance, let's say crop dusting, right? Will it actually make sense to have a simplified flight control aircraft do crop dusting instead of a drone? I don't know. My guess is, as you get into it, probably, that if you don't have a pilot on board, that could all be additional spray, right? That's the payload, right? So I think you really have to look at it on a case-by-case basis. For our particular mission, I can say that, having a pilot on board is absolutely necessary, because it's all about getting a trained professional to the scene of an emergency as quickly as possible.
What are the remaining standards that need to be written and agreed by the industry as it relates to electric propulsion, fly-by-wire, certain autonomy features? And what are the timelines do you expect in fleshing out these standards? And what are the timelines for this NPRM?
Yeah, so let me start with the last one first, is that I would expect that there will be a lot of comments on this NPRM because of the magnitude of what's being proposed here. And I believe that hopefully we will have the rule in place within a couple of years or so. We'll see. I do expect it's going to take, a couple of years to actually have the final rule language all hammered out. This is a big change. Let's go back to what were your earlier questions. I got hung up on the last one because it will take some time. So we do have a little bit of time to get our standards together. In the meantime, there are a lot of standards that have already been written on electric propulsion. There are standards that have been balloted on propulsion batteries and thermal runaway containment, and so a lot of that work is already well underway or has been published out there today. The fly-by-wire side, there is work underway as well on fly-by-wire systems. The committees that are doing that are looking at previous special conditions that were accepted by the FAA for fly-by-wire aircraft. Today, fly-by-wire aircraft are all done by special condition. So it's actually should be very useful to have the industry consensus standard process. So there's an effort going on right now for both. There's a published standard for indirect flight controls and for the human factors side of the handling for fixed wing aircraft. And then that effort's going to move forward into eVTOLs. And there's a lot of back and forth going on right now because we're looking at how Joby in particular, which is the eVTOL company that's farthest down the path in terms of their maturity for powered lift cert, what mission task elements or handling quality task elements they're being asked to demonstrate to the FAA as part of their cert process. So that's going to be a very relevant precedent for the entire industry to look at and say, okay, there was obviously a lot of thought that went into this. Let's see if we can capture that and build consensus around something that is approximately like that the industry wants to propose as a general standard. So that there is work to be done, but there's a lot of work that's already been done.
What's the effort on the other side of the Atlantic, and how do you see the harmonization as it relates to MOSAIC? And even back, I mean, the LSA category in Europe is somewhat similar to the one that's defined by the FAA, but perhaps a bit more restrictive in certain instances. How do you think that this evolves in Europe?
That's an excellent question. And honestly, unfortunately, the EASA and the FAA have been divergent. There was harmony on Part 23, Amendment 64, and the CS 23 also came along with the same. And then since that time, we have not seen, honestly, meaningful results in terms of harmonization. There's lots of good talk around harmonization. Everybody says that they want it. But when you look at SC-VTOL and you look at the process of 2117B and means of compliance, there's not practical harmonization happening right now. There's talk about harmonization. So I don't know is really the long and short of it. And right now, because LSA in general was never really fully harmonized construct between the US and Europe, there were many other countries that did accept LSA. Australia, New Zealand, I think Brazil had effectively allowed bilateral LSA. But in Europe, it has always been a little bit different. And right now, I really don't know what the likelihood of basic category SC-VTOL being changed or replaced. I think that's pretty unlikely, honestly, just based on the relative maturity and the position that EASA has taken with respect to these new advanced air mobility aircraft. I would love to see it change, but I at the moment, I don't think it's particularly likely. I'm not betting on it.
If my memory is correct, in the US, the FAA approach sort of forks the LSA aircraft into two categories. One's the experimental, and the other one is special. The first one being the owner builds it from a kit, and the latter being that it's factory built. And so if it's factory built, then you can use that for hire, for instruction, for certain limited commercial use cases. And you don't have to take that through certification, obviously. But with EASA, it is still fully supervised by EASA, and you still need to go through an official certification process, which adds cost. I think even further, the equipment needs to be certified. So in a way, it is slightly easier than going through the traditional CS23 process, but still not as streamlined as the FAA approach. Would you agree with that? Is that a fair assessment?
Yeah, I do agree with that. And then it's very interesting because there has been enough interest in this emerging advanced air mobility space that there is an element of national competition that is certainly at play here. Whether it's between the US and Europe, and while nobody will say that they're competing on safety, and they're not really competing on safety, that it is nonetheless that their companies are competing for market share. And especially, it's going to be very interesting to see how China plays into this as well. That's sort of the unknown potential 900-pound gorilla in the room that we really don't know where the CAAC is going to land with respect to these sorts of things. In general, they've followed, but in advanced air mobility, they are showing some willingness to potentially lead, which will likely further nationalize the standards and the competition, the national competition, the race that's going on for this emerging market.
On that note, what do you think is the true motivation by the FAA in introducing the proposed MOSAIC rule? You can argue the FAA has been looking at the amateur, the kit experimental category and saying the accident rates are really so much worse. We need a channel to introduce new technologies to improve safety. So that's one angle to look at it. But the other angle is saying, well, the LSA is still 4, 5, 6 times less safe than the certified category. And by extending this MOSAIC rule, we're really shrinking the certified market potentially and introducing LSA with a little bit worse safety track record. What else really do you think is behind this? And how would you place that in the broader context of continuous increasing pressure on FAA to be more accepting of new technologies in the context of drones, AAM, GA market?
Yeah, so I do want to push back a little bit on the numbers that you were throwing around. I mean, I'm not saying that they're as safe as certified aircraft, but I was just looking. In fact, we had a good presentation at Oshkosh regarding the operational safety of the LSA fleet. And so what I'm looking at right now is fatal accident comparison chart showing fatal accidents per year. So I'm looking at what they're calling personal general aviation versus SLSA is actually approximately the same. They're both around 2 fatal accidents per 100,000 hours. The experimental level is about 4, although in 2021 it was down to 3, which was interesting.
That's great to hear because my data is probably outdated maybe 5 years ago, but I remember seeing, and I'm quoting off the top of my head, GA had maybe less than 1 fatal accident per 100,000 hours, and then maybe 5 or 6 overall accidents per 100,000 hours versus LSA, which had, I think, close to 5, 6 fatal and maybe 30 overall accidents.
So
it may be explained by the difference between what GA encompasses and what Carl referred to. What was it, Carl? Personal?
Yeah. So that they're calling personal, and I don't know if that is Part 91 operations that are not commercial. That may be the distinction there versus you can do some commercial operations under 91. So that may be the distinction. So because it is showing fairly steady, the personal rate back in 2011 was at 2.5 fatal accidents per 100,000 hours, and now is at about 1.8 fatal accidents per 100,000 hours. But the SLSA one has a lot more noise because the fleet is smaller. So there was a spike in 2016 where that year was a bad year for LSA, and we were up at 5 per 100,000 hours, and personal was at 2 that year. But most of the time, and I'm happy to share these charts. This is right from the FAA, their presentation that they gave us at Oshkosh. Most of these years, like the SLSA numbers, basically on par with personal aircraft. I'm not going to claim they're exactly the same, but if you look at the lines, they're pretty much overlapping. And there's some years where LSA has actually been safer than there's just more noise in the LSA data. So anyway, I got a little hung up on that because it wasn't consistent with the numbers that I had seen. So the FAA, their primary job is safety, no matter what. I'm sure there are political influences at the high levels, but honestly, the rank and file really do care about safety. Like they really do. They know that that's their primary job. So as far as why would they do this? Maybe at the highest level, there are political influences and it could be a national competition kind of thing, which certainly, that is a market reality. But why would rank and file FAA staff be on board with that? It's because there's the potential of actually meaningfully reducing the incidences of loss of control in flight. And that's something that we just have not been able to tackle in a meaningful way. We haven't moved the needle on that particular thing in a substantial way, really, for decades. This presents the opportunity of addressing it in a substantial and lasting manner, and also the opportunity of opening the market, right? So it's sort of a win-win. I think that anybody inside the FAA will say it's safety. That's what they care about. That's all they care about.
Well, I know Jim's been dying to get back on the economics question on Jump Aero. So,
hey, thanks, Luca. Hey, before we get into the detail of Jump Aero and the economic justification and the return on investment, there's a couple of things that you mentioned that were really interesting as it relates to the potential of introducing a lot more vehicles in the space where pilots wouldn't have to go through the traditional level of training that they would for a lot of different types of aircraft today. So talk a little bit about that. Is there the potential of a lot more personal flying vehicles being introduced where pilots could be flying a more automated plane and wouldn't require the same level of training that they receive today?
So I would say it depends. There is the possibility with the simplified flight control aircraft and this construct that a manufacturer could decide to bring a product to market that is basically a push button, enter your flight plan here, and the aircraft basically flies you there. And technically, you're the pilot of the aircraft. You have the ability to command a landing at any point. So you're in charge. You're the pilot. You're in command. You're on board the aircraft, but you don't know how to fly a traditional airplane, right? Now, how many new pilots could come to market and demonstrate proficiency on that type of aircraft to the appropriate standards, right? Where most of the handling of the aircraft is all done by the computer. In my mind, that presents a huge opportunity to open market, right? How many people would buy a personal commuter aircraft if they could afford it, but they don't want to put in the time to become a pilot? They don't want to, it costs a lot to become a pilot and it costs a lot to buy the aircraft. Well, now, if there's actually a way of potentially both improving the safety and making it a whole lot easier to actually fly the aircraft and become a pilot through this channel, then does it make sense to invest in significantly larger levels of production, significantly more, types of production that doesn't make sense for traditional GA market size, but could make sense if you actually could make the case for, hey, I can sell 10,000, 20,000 a year, instead of 200 a year or 20 a year, right? Which is more the traditional GA market. There's the opportunity to get into one of those positive self-reinforcing cycles that can really be disruptive with this rule. That's the thing that I see as a real opportunity. Now, how quickly would that happen? I don't know, right? The rule is not official yet. There's an NPRM out there. That's a great sign. But would I plunk down, however much capital it would take to bet exclusively on that? And right now, no, probably not. You probably want to wait and see, does this actually become a real rule? And if it does, it's going to open a lot of doors. In my view, it's going to open a lot of opportunities that just don't make sense today. There's no realistic path to bring a product to market that has the potential volumes to justify, low cost and the beneficial cycle of, okay, higher volume means lower cost means more market, et cetera, and really open up the quote unquote the dream of the personal aircraft that is made in large enough volumes that the average person can actually afford it. It all comes down to the economics of it all. I do think there are fundamental limitations on that because you're generally driven to using more expensive materials fundamentally for aircraft than you are for cars. But there's definitely a potential to find an equilibrium point that is way closer to automotive than where we are today. And that's exciting. Where is that equilibrium? I don't know. I think you're going to have different companies that are going to place different bets, and some of them will pan out and some of them won't.
Carl, we've only been dabbling in the discussion about Jump Aero. Would you like to tell us a little bit more about the company?
I love to talk about my company, Jim. So to me, Jump Aero is really exciting because, look, even before MOSAIC, we thought this was by far the best potential rate of return on investment for an aircraft development program because it was going to be a level 1 cert project instead of a level 2. It was fundamentally opening a brand new market that is a $13 billion a year market potential. And, whether it's us operating the aircraft or preferably us selling the aircraft to operators that capture a significant chunk of that $13 billion a year market potential for bringing this life-saving capability to rural America and rural parts of the world at large. Also, I want to point out that our first customers are Falck, which is based in Denmark, but has operations in 14 countries around the world, including the USA. And we just announced yesterday an order of 10 aircraft by Electro Ventures down in Australia. And we're forming a strategic partnership with them to help support our operations in the Asia Pacific region. So a lot of exciting stuff going on, whether or not MOSAIC happens. If MOSAIC happens, it's just going to be yet another accelerator for this particular use case, which is really great because then the FAA can legitimately say, hey, we're completely out of the way on this. It's entirely up to industry. It's entirely up to, guys like Carl to write standards and that we'll accept as means of or not even means of compliance, but as acceptable design standards for eVTOL aircraft for these novel missions that heretofore weren't conceived of use cases for aircraft. So to me, that's really exciting because you have genuinely a brand new greenfield opportunity. We're the first to put our stake in the ground and say, we're going to be a big player in this emerging market for first response use of eVTOL aircraft. we're going to be the leaders in that space. And it's because we're the first really to recognize the opportunity to really optimize our aircraft for this novel mission. And to me, that's really exciting. I think we're in a really nice spot. And I'm really happy to be working with really experienced first response companies and people around the world who hear about this use case for an eVTOL who say, "Oh yeah, that's a great mission. That should happen. We should make that happen." And we're like, "That's awesome. We're working on it."
Carl, very innovative with the first responder vehicle use case. You can definitely see the physiological value of getting a vehicle to someone who's in distress faster. And you can definitely see the benefit that potentially could come from it. My question is, and my curiosity is, and I'm not even going to call it skepticism, perhaps, but who's going to pay for the added value of the first responder who's getting to an incident or to a home faster? You have many different people who could pay for this. You could pay it out of your pocket, which I think is a limited market. You could have an insurance company pay for it. There's several different kinds of payers. You could have the employer, you could have the insurance company, you could have the government pay for this kind of service. But who are the different payers, and are they willing to pay a premium? And what I'm going to guess is a rather significant premium for a faster first responder response.
Yeah, great question. So there are a few different answers, and the answer changes depending upon the stage of maturity of the deployment of the technology. So right now, who's paying for it? Well, for one, the Air Force. The Air Force is paying us to develop this new technology. They're funding our first full-scale proof of concept aircraft. Falk, one of the largest global first response companies in the world, has put down money to hold a place in line to buy multiple aircraft from us. So there are operators of the aircraft, like those companies, that are willing to pay now for the option, basically, of being able to have this capability. As we move forward and as we get these aircraft out there, so let me start by saying we've done the market research here. We've surveyed over 500 rural Americans. We've described the potential of this service. They know that this is a problem, right? If you live out in rural America, you know that it's going to take a while to get help if you call 911, right? It's not like this is some mystery problem that's out there. They know it's a problem. It's just a reality of living in a really rural place. And 80% of them are willing to pay something. We have the statistical data to back that up. 80% of them are willing to pay something for faster response for this particular type of service. That suggests that in the long run, this will just be a slight increase in the rural tax basis. If you live in a rural county, it will wind up being just a public service. To get there, it's not going to start as that, but we have the data that suggests it's going to wind up there, right? Like that's where it's going to be in the long run. To get there, you have to go through the stages of development where we're working with people that are paying now, right? Air Force, big companies, that sort of thing, that want to get ahead, want to have a potential piece of that $13 billion a year market. Why is it a $13 billion a year market? Because we ask those rural Americans what they're willing to pay for that sort of service. And when you look at all that data, you say, okay, well, we could potentially, or Falk or somebody else could potentially deploy a subscription-based service before the rural tax basis, before you have the public support for rural tax increase. You could just go directly to the consumer and you can offer them that service directly as a subscription model. And there's precedent for this right now in terms of helicopter air ambulance services that will offer subscription services if you live in a very rural area to offset the cost of what could be a $20,000 flight if you have to get airlifted out of your rural home to get to a hospital or something like that. So there's already a market there. This is different, though, because that's not first response. That's not helping get the first boots on the ground. That's after you've already been stabilized and they're trying to transport you somewhere. This is the first boots on the ground. This is the actually bit that has more life-saving potential. And so we've asked over 500 rural Americans what they're willing to pay. And the bottom line is that about 32% of them are willing to pay about $2 a day, about $60 a month, for a subscription service that would get them help faster when they need it. And that translates to about a $13 billion a year domestic market for this type of service. So we offer this up to our customers and say, here it is. It's a greenfield market. Nobody's doing this right now. Our vehicle can enable you to get access to this market, whether it's going to be Falk, whether it may be a health insurance company. By the way, that's another angle, is that the health insurance companies actually stand to save about $4.2 billion a year on healthcare outcomes just from getting help to the scene faster.
Here's something I'm having trouble with. There's a sticking point. I'm having a hard time believing that a payer is going to pay a significant premium, which your vehicle would be, over an ambulance or some other type of ground-based emergency response. Help me out with that a little bit.
So the way that you look at the unit business model, which I think is sort of what you're getting at here, is you look at how many people can that single ambulance, and it's staffed by 2 people, right? An ambulance and a team of 2 people, let's say you're staffing it around the clock. How many people can that ambulance and that team of 2 people get to in that time critical window of 8 minutes? In rural areas today, generally speaking, you can't get to very many people. The enabler that our aircraft provides to this market is that we can reach 10 times as many people on average than an ambulance today in that critical 8 minute.
Thank you, Carl. I'm not questioning as much the capability of your aircraft. I'm not questioning the ability to be able to reach more people. I'm not even questioning the value of getting to somebody faster, again, from the standpoint of from a life-saving standpoint. The thing that I'm stuck on is the willingness. I mean, look at where hospitals are today and the profitability, and a lot of them are having an awful lot of problems as far as, making money. And when you look at the healthcare system and you look at what they're willing to pay for, the question I'm stuck on is the willingness for somebody other than the consumer themselves willing to pay a premium in order to be able to provide this kind of value to their group. So I think there's a possibility that the individuals may be willing to pay, but my sense is it would be extraordinarily difficult to be able to get the number of consumers who are willing to pay directly. For example, through the subscription that you talk about, where you would have to be able to get some kind of a payer, be able to participate, to be able to allow this to be able to scale.
So let me take a minute to respond to it. So to a certain extent, because we have a direct-to-consumer model that can work, that we've got the data that suggests that over 30% of rural Americans would be willing to pay that amount of money to get faster first response service. That can just be it. It could just be that, right? Like that is right. You could bypass the whole thing, right? So that I hear what you're saying, and I hear it, like you're concerning about the existing system. Well, yeah, we can bypass it, right? Like that's the one of the beauties of this. Now, that doesn't mean it makes sense to bypass it in every case. It just means that we have that option, right? Like that we could go and do that. The other nice thing is, like, if you put yourself in the shoes of a county medical director, and these are the guys who are in charge of the emergency services in a given county, and a rural county medical director, like you're saying, has no budget for an airplane in general, right? They don't have, that's not inside their tax funding or anything like that, right? But they're judged nonetheless on their performance. Their performance is like, what are your health outcomes? We can offer up to those county medical directors a way to improve their numbers, improve the outcomes for their constituents without costing them a dime, just by allowing us to operate in their county with that direct-to-consumer subscription offering. So that's a very compelling sales. Like, it's not going to cost you a dime. You just have to let us do what we can do. And, we'll offer this service, and if people want to pay for it, they can sign up. If they don't have to, right? And so it's not a required thing. The data that we've got suggests that there are enough people that are willing to pay, and you have to go into areas with certain population densities, and all the numbers have to work out. But it turns out you need like around 800 people who live in your service area in order to make a unit business work, and who are willing to pay $60 a month, right? And that's in an area that is about 2,800 square miles. So we need 800 to 1,000 people in that 2,800 square mile area to be willing to pay that subscription rate in order for the business to make sense. But the cool part is that, in theory, based upon typical emergency response rates, one aircraft could sustain up to maybe 10,000 or so customers in that service area. So what that means is you've got the potential for tremendously high return on assets from that aircraft, much higher than what you get in any sort of airline business model. And that's another thing that I love about this business, is that because the customer is paying for availability, not paying for the time that the aircraft is in the air, the potential return on assets is extraordinarily high. And it's just a fundamentally different business compared to air taxi, which is basically just an airline business model. So it's really, really exciting from a business perspective, the way this type of the economics will work for this new model.
Carl, you are a serial entrepreneur in the world of aviation and advanced air mobility. And in fact, we're one of the very early acquisitions in the AAM space with Terrafugia. What kind of advice would you give to entrepreneurs looking at this market and wanting to start a business here?
Make sure you're doing something different. I mean, I know that sounds a little
different, but right.
Well, but I mean, even if you're not, look, I'm not going to pretend that I have a monopoly on all the good ideas in aviation by any stretch. But all I'm saying is, I think I've got one good idea here. But what I would say is general advice. There are a lot of people who love aviation and who have made it their life, myself included, right? And we're always looking for, how can we make a buck doing the things that we love, right? So we're always out there, and there's a lot of us that are out there looking for the best way to turn our passions into our job. So you've got a lot of folks out there with a lot of great ideas. So my advice to entrepreneurs out there is, make sure that you know what the other guys in the space are up to, and that you're not trying to do the same thing that somebody else is already doing and perhaps has been doing for a little while. Because I see that happening a lot. There's so many people in it, and they'll take a slightly different take on different design or something like that. But to me, the really exciting things are what's opening fundamentally a new market, right? That's something that's going to not only get investors' attention of holy cow, this is a completely unknown market. Yeah, it's got all that risk associated with it, but if it's real, it's got a whole lot of upside, right? And that's certainly what VCs tend to look for, is that significant upside potential. And going into a crowded space is just generally never a good idea, right? Because there are a lot of smart people out in the world.
Other than what you're doing, what's the most exciting thing that you've seen in the market?
Oh boy, I do think that autonomy has tremendous amount of potential. There's a lot of potential opportunities in drone delivery. Obviously, with MOSAIC, the simplified flight control opportunities are wow, this is something that I'm still wrapping my head around. What could be done here? What would make sense? And when would it make sense to do something with that? It's a really exciting time in aviation right now. There's new technologies, there's new business models enabled by those new technologies, and new rules and new rules of the road, which is just amazing. So to me, this is a great time to be an entrepreneur in aviation. It's certainly the best time in my life. So I'm incredibly excited, and I would definitely encourage folks that are interested in being an aviation entrepreneur this is a great time to get in. Make sure you got your unique thing, and you're really well crafted, and you know what you're talking about, and you're highly differentiated from everybody else in the space. That's really it.
Well said. Thank you very much. You're a true thought leader, and we appreciate your time.
Awesome. No, I appreciate the opportunity, guys. Thanks.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and/or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.